Hi there, I'm Kathleen Jasper, and today we're talking about the Praxis 7814, which is the science section of the Praxis 7811, Content Knowledge for Teaching. So today we're going to talk about the life science section of the 7814. Let's get started. All right, so let's hop on over to my presentation here so we can jump right into the life sciences. Remember, life science has to do with the biology portion of this exam, and we're going to break that down looking at the blueprint really quickly and then hop into the questions. All right, so right now we're looking at life sciences here, and this is section 2 at 35% of the test, 13 to 17 questions. And remember, you're always going to be on the lookout for the engineering, technology, and application of science embedded in all of these questions here. Remember, it's going to be part of each and every question on the exam. So today we are in part 2, life sciences, which is biology. And biology is all about anything that has to do with life. So it's going to be organisms, cells, cell theory, DNA, heredity, ecosystems, systems within an organism like our circulatory system, skeletal system, things like that. And an even larger view where we're talking about ecosystems and relationships between and among organisms. So it's a big one. Biology is a huge part of science, and you will always find it in a science exam for teaching and for students who are taking it at the end of the year. But this is about 35% of the test. So we want to be sure we are very well schooled in the life sciences at the elementary level. Now, let's jump right into a test question so I can show you how this might look on the exam. So again, I'm going to work backwards, and I have photographs of the Atacama Desert that show fossils of fish in a rock layer. Well, I'm talking about life science. Love the fossils because that shows you the way organisms have changed over time. And also a rock layer, that helps to show time because I'm going to do it again. I'm going to do a very terrible picture, but you have layers in the rock, right? So usually it'll be represented in a graph, something like this. There's one layer, there's another layer, there's another layer, and maybe there's another layer just to represent the different layers. But the further down, it's terrible, I know, but the further down you go, the older the organism is. So not only do we have the fossils piece, which I like, we also have the rock layer, which helps to determine the age of something. So I like A. I'm just going to give it a little underline there. B, a short video showing archaeologists excavating a site at the Atacama Desert. Now, we have excavating a site. That's kind of cool, and a video, but does this have anything to do with anything? There's nothing specific here, like the fossils in the rock layer. I'm going to eliminate it for now. C, an interview with astronomers who work at the new observatory in the Atacama Desert. So an interview is cool too, but that's a lot like the short video. B and C are so related that I can almost eliminate both of them because I'm looking for one answer choice here, which of the following, and there's no choose all that apply at the end of this. So I'm only looking for one. B and C are too close and they don't really give specifics. So I'm going to cross them out. D, clay models. Okay, I like models. That's good. That show the special adaptations of different types of Atacama Desert plants. So I have different types, adaptations, and clay models. I also like D. So by working backwards, I eliminated B and C, and now I only have to choose between two. Let's go here to the question stem. Which of the following materials for the activity will best, again, we're always going to want to pay attention to that, help Mr. Makiska's students achieve the stated learning objective? Well, I need to figure out what the learning objective is. So now I can go up to the question. Mr. Makiska wants his students to understand that the preserved remains of plants, okay, there's those fossils, and animals can provide information about how a particular location has changed over long periods of geological time or geologic time. To illustrate the concept, he will guide his students through a classroom activity. All right, so we have two key things here. We have preserved remains, which are fossils, I should say, and changed over long periods of geologic time. That's the rock layer. That's how we figure that out. A is my answer. Let's discredit D really quickly. Clay models. Well, In this case, we have fossils, the real thing. That's even better than clay models. And you may like the adaptation word, and this is a distractor for you on the exam. They're trying to trick you here because we have changed over time. But adaptations have to do with heredity and natural selection. And this is where animals in different locations on the globe have some similarities and some differences because of the adaptations over time that they have natural selection and really by chance. And so D is more of a heredity question than it is about the rock layer and fossils and things like that. So I'm going to cross off D. Also, clay models, if you can use the real thing, which is show fossils here, is so much better than clay models. A has all of the elements necessary. That is the correct answer. All right, so number 5, again, these are all coming from the ETS study companion cited below. So let's take a look at our answer choices. I have diagram A, diagram A, diagram B, diagram B. All right, so they're asking you to choose which one's better. And I can see that I have diagram A here and diagram B. So let's look at the question here before I go any further. Which diagram should Ms. Smith use for her class presentation? And what is the best rationale for using the diagram? Well, right away, when I looked at this, I went straight to diagram A because it was more sophisticated than diagram B. I chose this because it shows many relationships between the animals and food sources. So I went ahead and grabbed A there. And then I was like, well, let me go ahead and check the question because I like the word relationships in science. It's like a good word. And the diagram for diagram A is much more sophisticated than diagram B, which is just a pencil drawing. So I fell into a trap. Let me show you why this could have gotten me if I were taking the test. Let's read the scenario here. Ms. Smith is beginning an instructional unit on where the energy for living things comes from. So that's important, where the energy comes from for her lower elementary grade students. She has found several diagrams available online to help students in the unit, but she only has time to use one diagram. All right, where does the energy come from for all living things? Now, this is part you need to know about biology, and you also have to apply that to this. Diagram A is a food web. This is a food web. And while it shows lots of different relationships between and among animals, what we're looking for is the source of energy for all animals. And what is the source of energy for all animals? The sun. Because the sun shines down on the grass or plants. The plants turn that energy through a process of photosynthesis into carbohydrates. Then the bug eats the grass, then the mouse eats the bug, then the bird eats the mouse. Energy flows this way. But all energy came from this particular resource. So it's not going to be diagram A. It's going to be diagram C, but not because hand-drawn pictures are more accessible to students. That's not what we're trying to do here. That has nothing to do with the learning objective. But it's D because all energy in animals' food was once energy from the sun. So D is actually the correct answer. I fell into the trap. I went with the most sophisticated one. That's why it's important to work backwards, but then go back into the question and the explanation of the graph to make sure we answered it correctly. And the last one for our life sciences section, and again, coming from the ETS study companion, let's look at the question stem first here. This activity will best reinforce which of the following ideas? A, plants and animals have different requirements depending on where they live. I've never heard about plants and animals having different requirements. I don't like that. I'm going to cross it off. B, plants and animals can change the environment to meet their needs. Can you change the environment to meet your needs? No, we cannot change the environment to meet our needs. We change other things inside the environment that can have a negative effect on the environment. Like, a wolf out in the snow can't change the environment so it's more, so it's sunny or so it snows more. That's impossible. So B is out. C, matter cycles through plants, animals, decomposers, and the environment. Well, that is actually true. Matter does cycle through. It's actually recycled. All matter on Earth is finite. It stays. It's neither created nor destroyed. But C looks good. So I'm going to keep that. And D, plants and animals have specialized characteristics that help them perform specific tasks. Yes, indeed. So like giraffes have long necks to help them eat the food at the top of the tree. And, little bugs have specialized feet that help them stick onto things. So yes, they do have specialized characteristics. So I've narrowed it down to C and D. Let's look at the scenario so we can get the right answer. Ms. Ling is designing an activity for her early elementary classroom that will require students to make physical models of bird beaks using spoons and toothpicks. Sounds like fun. The students will use the models to pick up objects of different sizes and shapes that represent different types of food. So we have different sizes and shapes and different types of food. Students will use their observations to determine which beak model is best to pick up each food. Well, this doesn't have to do with matter cycling through. This has to do with specialized characteristics. Long beaks to get into the dirt and get out worms and things like that. Short, dense beaks to break seeds and nuts and things like that. So D is actually the best answer choice here. And again, we narrowed it down in the beginning to 2 by not even having to read the question. That when we got into the scenario, we were able to narrow it down even more. So D is the correct answer there. All right, so hopefully that clears things up for you regarding the life science section of the 7814. Remember to go back and watch that first video where I go through the structure of the exam if you want to look over that study companion where all of these test questions came from. You can download the presentation I used today in the description below, and feel free to use the comments to ask questions or comment on this video. Please consider subscribing to our YouTube channel and giving this video a thumbs up and letting your colleagues know we are here. Lots of people need help with this particular exam. Thank you so much and have a great day.